Hi, welcome to the Calculus 1 lecture series. And the first things I like to do is do a kind of a quick review about what we learned in the pre-calculus and all this kind of the important skills we need to be successful in the Calculus 1. So I have this chapter 1 practice test. So basically in this practice test is covered all the key topics for the pre-calculus we need to know. So I like to go over with you for this the practice test, and then at the same time you can try to kind of refresh your memory about the pre-calculus. Okay, let's go ahead, take a look this practice test, okay? All right, so the first thing here is like we want to find the domain and the ranges here. So let's say write your answer in the interval notations here. So before we do that, right, so we kind of the refresh when we talk about the domains here. We, in the pre-calculus, we said we have three concerns, right? So the first one here is a what? So it's a denominator cannot be equal to zeros, right? So that's what we talk about in the domain. That's one thing we need to be careful. Then the next thing here we say the, the value inside even roots has to be what? Has to be greater than or equal to zeros, right? And then the third one in the pre-cal, we said for the log functions, okay, so whatever inside the log functions, the value inside here, log functions has to be greater than zeros, right? Those are the three main concerns. So we typically start with all real number. Then we kind of try to eliminate what happens here, right? So we said, okay, if I have a fraction, then the denominator cannot be zero. If I have even roots, then my inside value of my even roots has to be greater than equal to zero. And then for the log function, remember the definition of the log. So the value inside the log function has to be greater than zero. So those are the three things we care about the, like, I think a majority of the domain, the range function covered under these three areas. Okay, so let's take a look at the first problems here. So the gx is 16, square root of 16 minus x squared. So I know this is a square root, right? So that's why I know that in order to make this work, so the value inside the square roots has to be what? Has to be greater than equal to zero. Am I right? So, okay, good. So after that, then you will say here, this is 16 is greater than equal to x squared. Okay, so now let me switch around. So it's more like a traditional way. So it's basically is the same. X squared is less than, I'm sorry, this is x fourths. Okay, so if x fourths is less than 16, so the way we say, okay, if the x squared less than some value, so we can really break this one, say this is x squared less than equal to 4 and greater than equal to negative 4, right? Because this is basically we said here, that's we say if x squared is less than equal to a, then we said this one means is x is less than square root of the a and greater than negative square root of the a, right? That's from the algebra, we know how to break it. Okay, so now this is x fourths. So x fourths is here is x squared. So this one here is the x squared to the squares, right? So let's try to break it. Then from this side here, so I said x squared is less than 4, greater than negative 4. X squared always greater than 0. So this one really is telling us, so it's x squared is what? Is less than 4. Am I right? Okay, so it's x less than 4, and this one here is always greater than 0, right? Because now I do the x squared break one more time. So that means it's x is less than, you take the square root of the 4, so it's 2. And what is here? So it's negative 2, right? So this is the domains here. So if I write it, so this will be the -2 to the 2's here. Okay, and now we know that because x equal to -2 to 2's, right? And then the square root function that come out is always positive. So this is my domains here. Okay, so the largest values here, so if you put a 2 and -2 here, you will get a 0. So when you put x equal to 0 there, you get a 4. So I know the range is here. What is the range for these values here? It's going to be from the what? From the 0 to what? 0 to 4, right? Okay. Now let's take a look at the next ones here. So the next ones here, this is h of x is equal to the natural log x plus 6. So this one is pretty easy. We said, hey, here, the natural log, we say anything inside the natural log based on here, we learned in the algebra. So what is this one here? This one has to be greater than 0, right? Cannot be equal to 0, has to be greater than 0. So what I have here, so I have x plus 6 is greater than 0. So what is my x is what? Greater than -6, right? So my domains here are going to be what is -6 to where? To infinities, right? So the -6 is an open parenthesis. And then we know the natural log function. So what is the natural log function's ranges here is going to be from -infinity to what? To positive infinities, right? Because we know the log function is something like that, correct? So it's from -infinity to the positive infinity. Okay, now good. So let's take a look at the next ones here. The next ones here is f of x equal to, okay, so f of x is equal to the 2 over 3x minus 1. So as we mentioned, you know, for the domains here, you cannot have, because this is a fractions, right? So this one cannot be equal to 0. Okay, so that means, now let's take a look. So the 3x minus 1 equal to 0. Now what is my x here? X equal to 1/3, right? Because this is cannot be equal to 0. That means is a whole real number except this point, right? You can be here, you can be here. So what is my domains here? My domains here will just be from the -infinity to where? To 1/3, right? So this is going to be an open interval. And then the union, the 1/3, go where? Go to the positive infinities, right? Okay, now let's take a look at the ranges here. So the range, you know, this is fractions. The range, because the top here is a constant, right? So you will never be able to become to 0. So the f of x can be anything except what? Except what? Except zeros here, because the numerator is 2. So in order for a fraction to become to 0, the numerator has to be 0, you know, have to be 0. So in here, I know the ranges here can be any other number, but except zeros, right? So how do I write the ranges here? So that means that the range will be the -infinity to 0, union 0 to the positive infinities, right? Because that's what happened. It will never be able to become to zeros there, right? For the fractions here. Okay, so this is the, you know, the first part. Then the second problem here, we are talking about, this is the transformations, right? Okay, so let's take a look at the first ones here. So remember when we did it in the pre-cal, we said we always do one function at a time, right? Okay, so now let's take a look at this red line is my f of x. So the first transformation, we are doing this. Okay, so if you have, you know, if you have a negative sign in front of your functions, you know, don't know you remember or not, what is this one here? What type of transformation? This is what? This is reflect over what? refract over x-axis here, right? So like we talked before, we said let's try to use a dot line. So here, this is so this one going to reflect to here. Let me give a little bit of bigger space because in here we do need to, okay, so let's take a look here, right? So this way, if I extended it, so this is 0, 1, 2, 3 here. Okay, so according to the refracting, we are doing the first ones here, right? So this one is reflecting the x-axis. So this is a positive 3. So going to reflect in the 1, 2, 3, going to reflect into here. All right. Okay. So this one's here. So this one going to still reflecting over here, right? Okay. So now this point here, this is 1, 2, 3, 4, right? Okay. So that means I'm going to reflecting go down here. So I go to extended this a little bit. So that means that 1, 2, 3, 4. So it's 1, 2, 3, 4. This one going to go down here. All right. So now let's try to do it. So I'm using a dot line. The reason why I'm using the dot line is because this is not my final graph yet, right? So here, that's why we did the reflections here, right? Okay, now the next thing here is this 2. So this 2 is outside the function of f of x. So if you remember, what do we call this? We call this is what? This is the vertical shift, right? So this is 2. So that means every point going to shift up to 2. So this point going to shift up to 2 going to here. And this is 3, negative 3, shift up 2 is 1, 2, so going to here. This is a 4, right? Negative 4, so 1, 2, so going to shift up to here. Now I finish all the transformations, so I can have, okay, so after this one, okay. So now I use the solid line to graph it, so I know the red one, this is what is the whole transformations here. Okay, so now let's take a look at the next ones here is 1/2 f of x. So let's take a look here. So let's do this transformation. So if you times the function, that's what we call is the what? That's what we call is the vertical stretch or compress, right? Okay, so now let's take a look at times 1/2 here. So let's do this graph here. So this is 3, right? So you times 1/2 will give you what? Will give you 1.5 here. And this one's here, you times 1/2 still kind of is in here. Then like, for example, this one, you times 1/2 is kind of like go here, right? Okay, so these numbers here, this is the 4, you times 1/2, go where? Go here. Good? All right. So now in here, I'm going to connect it with the dotted line because I only did what? I only did one transformation. And now I'm going to do next one. So this is similar. This is outside the function f of x. So what I'm doing here, this is the vertical shift. So what is this shift here? Shift down how many? So this is shift down 1 unit, right? Okay, so I go to shift down 1 unit to here. So that means this one going to shift to here. And this one is 1.5, going to shift to the 0.5. And this one is pretty close to 0, going to shift down 1 units here. This one shift down 1 units. Okay, so now I finish all my, so I can connect it. Oh, this one should be a straight line. Okay, so it's very difficult to do a straight line here. So here. All right, so that will be my the vertical transformation. Now the last things here, this is very important. So we said this is what? This is the inverse function. So if you remember, so let's try to refresh the memory. So for the inverse function, which one they're going to be reflecting? So it's going to be reflect over what? Reflect over y equal to x-axis. So that's what is we call it the inverse function. It's going to reflecting over to the y equal to the x-axis. Okay, so the first thing is here, let's try to graph the, the x-axis here, right? So x-axis, so it's this is the, right? So that means I'm going to reflecting over here. Okay, so this is the f. So this green one's here. This is the one. This graph is supposed to reflecting over y equal to the x-axis. Okay, now let's take a look. How do I reflecting it? Okay, so refracting, that means, so this point, right? So this point is kind of like a perpendicular to here. So this point reflecting to here, right? Because both of them is kind of like a go like the have the same distance, correct? Okay, so this point is kind of like a reflecting here. So it's a perpendicular, have one diagonal and half of the diagonal. So where is this one going to reflecting? So this point going to reflecting to this point, right? Because I have a half of the diagonal and the whole diagonal here. All right. Okay. So now the next things here is this point. I need to extend it this a little bit. Okay. So in here, take a look here. This one's 1, 2, 3. So that means that this point is going to reflect into 1, 2, 3, going to reflect into here. Okay. So now take a look at this one's here. How do we reflecting? This one is a perpendicular, kind of like the one diagonal, two diagonals here, right? So then the same way, I'm going to reflecting the one diagonal, two diagonals here, right? So let's try to extend this a little bit, okay? So now in here, okay, so take a look, it's one diagonal and the two diagonal. So this is one diagonal here. Let me see here. And this will be what? This will be the two diagonal here, right? So here will be here. Okay, so let's see the graph. So this graph going to be, so sorry here, this one's here. So I'm sorry, this one doesn't have one because we already, so that's my fault. We're already reflecting the here. All right, so that I don't know, I cannot reflect over here. It's reflecting over here. It's perpendicular. So I'm sorry, while ago, this one is already reflecting. So this one's here is reflecting over here. Okay, now I can connect it, right? So this is the line. All right, so this is going to be a what? Going to be a curve, right? Okay, so now this red one's here, this is my F inverse axis here. All right, so you see that? So that means that for each one, you going to reflect into the y equal to the x. So what that means, the reflecting here, that means for the points here, you need to see the distance to the lines, right? So distance to the line, don't make mistake. I kind of did this one, then I did again. So this one is reflecting over to here. Then this one reflecting over to here. All right, so now that's it. Okay, so remember that. So this is the graph transformations. Okay, so now the next topics here, if you still remember, how do we define even functions and how do we define the odd functions here? Okay, so let's do a brief review and refresh what is the even and the odd. So we know what is the even function. That means if you replace all your x with negative x, this will be equal to the f of x. Okay, so then the other functions here, that means if you replace the older value of the negative x, this will be equal to the f of negative x here. So even function is basically what is we reflecting over what? Reflecting over the y-axis. And the other function is what? That means we reflect over what? Origin. Okay, that's what is we learned in the pre-calc. Okay, so now in here, let's say it's determined whether this is the even and odd. Okay, so let's go ahead and start. So f of x, so we always start with f of the negative x here. That means here is e to the negative. You replace the x with negative x. So it's negative x squared. And now here, this is e. So what is negative x squared? Is x squared. So it will be equal to the e to the negative x squared. This is exactly equal to the f of x. So what type of function is this one? We have even, right? Okay, now let's take a look at this one here. Remember, we always start with negative x here. In here, just be careful about the positive and negative sign. So this is x to the cube. So you have an x here, negative x to the cube. Be careful about this negative signs, right? So it's negative, and then the x is negative x to the 7th, right? Okay, so now I know in here, the negative sign to the odd power, what happened? Still is negative, right? So negative sign to the odd power is, so this is negative x cubed. Then minus, the same things here, the negative sign to the odd power. So what is this one here? This one is negative x to the what? To the 7th, right? Okay, so now be careful. See here, this is negative x cubed plus 7x. I don't have 7 in front. Plus, okay, it's plus x to the 7th. So you see, oh, it looks very much like f of x. That's true. So if you factor the negative sign out, so this will be x7, x3 minus x7. What is this one here? This is f of negative x. So this function is what? This is this is odd functions, right? Okay, so this is odd function. Okay, let's take a look at this one here. So let's start with the f of x. So we said that negative x is equal to the 1 plus sine negative x. I know the sine negative x is equal to what? From the trick, we know it's negative sine x, right? So this is negative sine x, and then this is not equal to the f of x. This is not equal to the negative f of x. So what is here? So this is neither. It's not even, not odd. All right. Okay, so this is the review for the even and odd functions, right? Okay, so now let's take a look at the compost function. And the compost function, mathematically, is pretty easy. The things for the compost function we need to be careful is their domains here. So the way I like to do is, let's take a write down the domain for each individual function first. So this is natural log. So what is the domain has to be? What is the domain has to be? The domain has to be what? The domain has to be greater than 0, right? That's what we learned here. So this one here is greater than 0. And then for the gx equal to the x squared minus 9. And this is what? This is the polynomial. So I know the polynomial. What is the domain? See here. Domain is all what? Real numbers, right? Okay, so now let's go ahead and start. Okay, so here, f of g, so it's f of gx. That means you replace whatever the functions here, right? So you need to, so because this is f of gx, so you replace the x in f of x with gx. So this is a natural log. So x is x squared minus 9. So it's x squared minus 9 here. And because the natural log from here, I know has to be greater than 0. So the domains here, that means x squared minus 9 has to be what? Has to be greater than what? Greater than 0, right? Okay. And so this one's here. So this is has to be greater than 0. So what is that? So if this is has to be greater than 0, so we will say the x has to be greater than 3, and x has to be what? Less than -3. So, correct? Okay, so I know the x cannot be less than -3, right? Because the x less than -3 f of a function is not going to work because it's a violated the domains here. So I know this one cannot be. So x greater than 3, well, yes, it satisfy both, right? So I know the domains here. So what is the domains here for these ones here? It will be greater than 3. So it's 3 to what? 3 to the infinity. So you need to look back to the original function and be careful, right? Okay, so now let's take a look at the next ones here. You say f compose f. So that means f of x. All right. So that means you need to replace whatever the f of x with f of x itself. Okay, so now let's take a look. So f of x is natural log x. So you need to replace x with another natural log x. Okay, so now let's take a look here. All right, so first things here, okay. So let's take a look at the first, for this natural log, the x has to be what? Greater than 0, right? So let me write it in a different color, has to be greater than 0. Okay, now let's take a look for this log, okay? If I'm looking for this log, that means whatever inside here has to be greater than 0, right? Because that means the natural log x has to be greater than 0. So that means what? X has to be greater than 1 because I know the natural log function is go like this, right? Okay, so this is where they touch the zeros here. It's positive and negative, so it's greater than 1. So let's need to satisfy both. So what is my domains here? The final domains here has to be greater than 0, has to be greater than 1. So the domains here has to be what? It's 1 to what? 1 to the infinity. Do you get that? Okay, so now let's take a look at the last one. This is g of g. So that means g to the gx, correct? That means you need to put whatever the gx into your x's here. So let's see here. So this will be the x squared. So it will be x squared minus 9 to the square and minus 9, right? So that what is this function? And then you see this function is what? This is the polynomial. So any x can satisfy. So the x in the R, so all the real number, correct? And it's a matched what is that doesn't violate this domains here. And this has nothing to do with f of x, so I don't need to worry about f of x. All right. Okay, so now the next thing here is how to find the inverse function. So let's do a brief review what we learned in the how to find the inverse, right? So what do we need to see here? So we set set the step 1. Okay, so we set y equal to the f of x. What is the step number 2? So step number 2, we said switch y and x. Then what is the step number 3? We said solve for y here. Okay, so now let's follow the steps here. We did a many practice in the pre-calc class. Okay, step number 1, set y equal to function. So you set y equal to x plus 1, 2x plus 1. It's good. Then step number 2, switch y and x. So y change it to x, x change it to y. Okay, so this is y plus 1, and this is 2y plus 1. All right. Okay, now let's solve it. So x, so what I can do here? I can treat x is equal to x over 1, right? Then I can just do a cross product and try to solve for that. Okay, so now I can have x times 2y plus 1 is equal to the y plus 1, right? Okay, then distributive property, 2xy plus x equal to y plus 1. Because I want to solve for y, so I need to move all the y to one side. So I minus x both sides. So I will get a 2xy equal to the y plus 1 minus x. Right now, I minus y on both sides. So this is 2xy minus y equal to the y minus x. Then in order to solve for y, what I need to do, I need to factor the y out. So this is 1 minus x, right? Then I will divide by 2x minus 1, 2x minus 1, both sides. So when you divide by 2x minus 1, 2x minus 1, your left-hand side cancel. So what is here? So y is equal to what? It's 1 minus x, 2x minus 1. And this is our inverse, right? So remember these 3 steps. It's pretty routine and very mechanical steps here. Okay, so let's go ahead and take a look at the problem number 6. Let's try to solve the following equations here. So in here, we need to use the sum of the log property. Let's do a review for the log. I think you all should remember. So it's like a log. If you have the same base, x plus log the by, so this will be equal to the log b x times y, right? So I think everybody know that. And if you have the same base, the x minus log by, what is this become to? This become to what? X over y, right? Very good. And then we also said log bx, if you have some constant in the front, so what can you do? This one will be, you'll be able to bring that up. So this will be, you can put it to the x to the c's here, right? Also, we know the log function and the exponential functions, they are what? They are the inverse, so they cancel out. So what's that mean? That means if you have log b, and here is b to the x power, right? So because this b and this base b the same, you can kind of cancel that out. And what is this one here? Will be x here. All right. So the same things here, you know, if you have like a b, then here if you have log b to the x here. So look here. So this is the b and this is the base b. So these two will cancel, will give you x. So the special things here, if b is equal to the e, then this one we can simplify, we say e and the natural log x, e and the natural log cancel, this will be equal to x, right? So we need to use those properties here. And I assume you should be very familiar with those properties. That's what you learn in the pre-calc. Okay, so now let's take a look here. All right, so the first one's here, the e to the 2 natural log 3. In order to use the property to cancel out, I have some problems here. So here I have a 2 in front of it. In order to prevent me to cancel out, I need to just e and the natural logs here. So what should I do here? First things I need to do is I need to move this to the inside. So I use this property. So this one will give me what? Natural log 3 to the what? 3 to the cube. Let me erase it so I can write bigger. Okay. Okay, so maybe it's, so this one here would be e. You move this 2 to the inside. So this is natural log 3 to the what? 3 to the 2. And now take a look here. You have e and the natural log. What happens? They cancel out. So that's why you get a 3 to the second. So it's 9 here. Okay, so now let's take a look at part B. So part B, this is like they have the same base, it's 10, then they add. Okay, so remember what is the add? Is the first property, it will be equal to the log, the base, then is 25 times 4. So what is 25 times 4? It's 100, right? So what is the hundredths here? So this is 10. So this is 100 is 10 to the what? 10 to the square. Then take a look here. You have a base 10, you have a base 10 here. So these two cancel. What is the final answers here? This one is equal to what? Is equal to 2, right? Because every time you see the log and the exponential, they cancel out. Okay, so that's about the log. So now let's take a look at the arctangent sine. Arcsine is 1/2. That means I need to find the angle to give the arcsine is 1/2. So remember for the arcsine, we know my domains here, the theta has to be from the pi over 2 to the negative pi over 2, right? So I mean the range for this one's here. So what angle will give a sine 1/2? So I know the angle will give a sine 1/2. What is here? The angle is what? 30 degrees or pi over 6, correct? Okay, so now that's why, so these numbers here, this will be equal to tangent pi over 6. So what is the tangent pi over 6 here? The tangent pi over 6 is equal to the 1 over square root of the 3. All right, or if you want to rationalize a little bit, so it's square root of the 3 over 3. Okay, so this is we use in the arctangent properties here. Okay, let's take a look at this is the sine, cosine, cosine 4/5. So I know if you see this notation, that means there is angle theta. Okay, so let's see. So this is my angle theta. This is 90 degrees, right? So cosine is adjacent over hypotenuse. So it's 4/5. So I know adjacent is here, hypotenuse is here, right? So it's 4/5. Then based on the Pythagorean theory, what is this side here? This side is 3, right? So now in here, this one is changed to the sine theta. And so now I know what is the sine theta. Sine is opposite over what? Hypotenuse, right? So what is the final answer? It's the 3/5 here. All right, okay, so and this one's here, the cosine here, this one is in the first quadrant here, right? So the cosine, because this is a positive numbers, right? So it has to be on the first quadrants here because we know the arctangent, the theta is from what? From the 0 to pi, right? So that's why the 0 to the pi over 2 is give you positive, pi over 2 to pi give you negative. But here's a positive, so I know the theta is in what? In the quadrant 1. So that's why your sine got a 3/5 here. Good. All right. So that's good. All right. Okay, so now let's take a look. How do I solve for x here? So we talk about how do you solve for x. So we want to use the log property again. So here is e to the x. So I can say I'm taking the natural log of both sides. All right. So I take the natural log of both sides. Good. So when I take the natural log of both sides, here, this is natural log and the e. What happened? So this is cancel. So that's why I only have x equal to what? Natural log of 5. That's pretty easy, right? Okay, so now the b is natural log of x to the 2. So what I need to do? I take exponential both sides. So I will say, hey, I took the exponential both sides. So it will be equal to the e to the 2. I put its exponents. And now in here you say, oh, this is good. E and the natural log, they are inverse, so they cancel. So what is your x value? X value is equal to what? E to the 2, right? Okay, so now let's take a look the part C here. Oh boy, I have E and E to the X. Well, I said, okay, I just need to be patient, one at a time. So I take a natural log E, both sides, right? So this will be the natural log 2, right? So I take the E both sides. Okay, very good. So hey, these ones here, I take care of the one, right? Okay, so good. So I will have EX equal to the natural log 2. So I say, okay, let's do the natural log one more time. So this is the natural log E to the X. So I take the natural log 2 again. So I double that. So I take it one more time. Then here you say, oh, that's good. The natural log, this one, they cancel. So what is the X here? So X is equal to the natural log 2. Cool, huh? All right. So part B here. So this one is pretty easy. So this is arctangents, right? So, you know, in order to get X, that means I know that means whatever the value of X is the angle 1. So this is the X is equal to what? X equal to the tangent 1, right? That's how do you transfer back. Okay, so now let's take a look at the exponential, the last province here is the, we're going to use the exponential things, decay over growth, right? Okay, so first let's do a fresh review. What do we learn in the before? Okay, let's do the review. So if you remember the exponential growth and the exponential decay, we always use the formula. We call it A equal to PERT, right? You got to remember PERT, P-E-R-T. Okay, so that is what do we call it? It's a PERT here. Okay, so now the first things here, let's say, okay, so the half-life of this palladium 100 is 4 days. That means after 4 days, it's going to drop to a half, right? So the initial mass of the sample is 1 gram, okay? It's 1 gram, see here. That means the P is what? P is 1. Okay, so let's take a look, see here, find the mass after 16 days. Yeah. Okay, so first things here, I need to find the R's, right? So after the 4 days, the mass dropped, become half-life. That means my A become what? Become one half, right? Because after 4 days. Okay, so let's write it. So that means 1/2 is equal to E R. What is the T? Half, 4 days, right? So I want to solve for R. So how do I solve for R? I take the natural log of both sides. So this is the natural log 1/2 is equal to the natural log ER4. It's just like we did before. Hey, this is a good news, right? So this is a cancel. So now I can get this one's here. So I say R times 4 is equal to the natural log of 1/2. So what is my R? The rate of the R is equal to, you divide by 4, both sides, natural log 1/2. All right. Or if you want to write a little bit different, so this is 1/4. Natural log 1/2, you can write is 2 to the -1, right? Now you use the natural log property, move this one inside, okay? So that's what you can do here. You can get the rate is the natural log 2, the -1/2, 1/4, right? Okay, all right, so now they ask you what is the amount for the 16 days, right? So the amount for the 16 days, however, okay, so that means the A is equal to PERT. P is 1. E, what is R? Natural log 2 to the negative 1/2. Okay, let me erase this PERT. So I have a little bit more space. Okay. Okay, so now, now I'm looking for how many days? 16 days, right? So in order to be able to cancel that out, okay, so here, this is E. So then I need to move the 16 to here. So I have a natural log 2. This is negative 1/2 times 16. Now I can use the exponential here. I can cancel that out. So I will have is what? This is 2. 16 times negative 1/2 is what? Negative 4. So this is 1 of 2 to the 4. So it's 1 over 16, right? So that means after 16, I'm going to have 1 over 16 grams here. Okay, so then the part B, let's say find the mass after the T days. So basically they wanted us to find the general formula we already did from the part A. So you say A is equal to the PERT, P is 1E, then the RT is the natural log negative 1/4, right? And times T here, that's right. So now you move the T is inside. So it will be E to the natural log negative 1/4. And what? You have natural log 1/4. And I'm sorry, here we're missing the 2 here. Right? So okay. Need to be careful, cannot be rushing through. So this is 2 to the negative 1/4. Then you have a T's outside. And now, use the log property, move the T inside. So this is 2 to the negative 1/4 T. So as you can see here, I have this again. So that's good. So can cancel. So now my answers here, this is my general formula. It's negative 1/4 times T, right? So now the C, they say, when the mass will reduce to the 0.01. Okay, so that's basically, I'm using this formula. So I say that now the mass is 0.01 is equal to 2 to the negative 1/4 T. Right, so how do I do this? I take the natural log of both sides, so it's 0.01. Then this is natural log 2, negative 1/4. What here? T here, right? So now in order to solve this one, I can move this to the front. So here I will find this is negative 1/4 T, then the natural log 2. Then you can plug in the value of natural log 2 and the natural log 0.01. So the T is equal to what? So the T here, right? So going to be equal to the negative 4, right? So negative 4, the natural log of 0.01, and this is natural log 2. Get that? Okay, so now you put it into the calculator and you will get something like, I'm just like a 26.57. So it's approximately to the 27 days, right? So for this material, after 27 days, then the amount going to remaining from the 0.01 grams here. Okay, that's it. And this is a kind of a brief review about what we learned in the calculus 1, not the calculus 1, the pre-cal, and some key concepts we need for the calculus 1s here. Okay, and so the hope that you find this helpful and to help you to go through this practice test. Okay, that's it, and looking forward to talk to you in our next topic. All right, and bye. Have a good day. See you. Bye-bye.